So to configure sub-interfaces on the frame relay interface, we have to decide whether the sub-interface are to be point-to-point or multi-point. Now, with respect to the problems that we have just mentioned just now, we would create one PVC report to a one sub-interface solution. To work around the split horizon solution, what we would do is we will have one PVC report to one sub-interface. To do so, we would choose the point-to-point option when we create our sub-interfaces. So at the end of the day, each PVC will be reporting to a different sub-interface. With this deployment strategy, we can work around the split horizon restriction. But using a point-to-point configuration does have certain requirement, because each PVC reports to a different sub-interface. Each sub-interface would need to have its own IP subnet. So in this example, you would need 3 subnets, 3 sets of IP addresses for deployment as part of your deployment requirement. Now, there is this option called the multi-point setup, where we create a sub-interface, for example, and still have many circuits report to the same sub-interface. Now, if you have many circuits report to the same sub-interface, we will still have the split horizon issue. So, routes coming in from a sub-interface, a multi-point sub-interface, would not be able to go out to other sites through the same multi-point sub-interface. But maybe this is something that you are okay with, because with the split horizon issue not resolved, the remote sites cannot learn each other's remote routes. They will only see the HQ routes. But maybe that's okay with you. Maybe for security reasons, you might not want the remote sites to learn each other's route except the HQ routes. So in this kind of deployment, you can use a multi-point scenario. Now, one of the advantage of using a multi-point sub-interface configuration is that because all the sub-interfaces report to the same sub-interface, an IP address deployment is determined by the number of interface you have, not the number of sub-interfaces. So as you can see, all the circuits report to the same one sub-interface. As such, we only need one single subnet for all the connections. So all these connections only need one subnet. Now, this is an example of how we can configure a frame relay point-to-point sub-interface. Here, the 00 interface has been enabled with frame relay encapsulation. So this is a prerequisite. Okay, so this is a prerequisite. Of course, other things is make sure the main interface is not shut down. Then we can proceed to create sub-interface using the sub-interface notation, and then followed by the type of sub-interface that we want to create. In this example, we want to create point-to-point sub-interfaces. Okay, sub-interfaces. So here we have created 0.110 point-to-point, and another sub-interface that we have created is S0.120 point to point. Now, we know that LMI will tell the end user interface what circuits they are entitled to receive or use. But LMI doesn't know what sub-interface to assign the LMI, the PVC circuit to. LMI only tells you what circuits interface you can have and give it to your main interface, your S0. Now, if you want to create sub-interfaces, you have to manually move the circuits to the appropriate sub-interfaces. So in this example, besides creating the sub-interface point-to-point, in this case 2, we also have to configure manually which PVC circuit is reporting to which sub-interface. We do this by using the command frame relay interface -DLCI, the respective circuit. So in this example, after creating the sub-interfaces, we use the command frame relay interface -DLCI 1110 for this particular sub-interface, and we use the same command frame relay interface -DLCI 120 on the other sub-interface. So what this means is that circuit 110 is now reporting to the sub-interface 0-110, and that circuit 120 is associated with this particular sub-interface. Now, this example shows you how to create a multi-point sub-interface configuration. Now, bear in mind this is just one of the way of configuring many circuits to report to one sub-interface. Now, in this example, same thing, S02, we have to enable the frame relay encapsulation first by using the command encapsulation frame relay. Then we can create the appropriate sub-interface with the preferred sub-interface type. In this case, we create a multi-point scenario. Now, as the name suggests, multi-point means many circuits can report to the same sub-interface. So here we can see that circuit 120, 130 and 140 all are associated with the same sub-interface of 2.2. Now, in this example, using this method of assigning 3 circuits, 120, 130 and 140 to the same sub-interface, using this method of configuration, there is an assumption behind, whereby we assume we are going to use static DLCI to IP mapping. But you don't have to use this solution to do the mapping. You can also create the sub-interface. You can create the sub-interface in this example as 2.2 multi-point, for example. Instead of using the frame relay map command to associate circuits to the same sub-interface, we can simply use the frame relay interface -DLCI command to associate (120, 130, 140) to the sub-interface. Now, using this way of assigning 3 circuits to the sub-interface, we do not assume that we are using a manual mapping. So here we can have a multi-point connectivity with a inverse up function enable. In this example, we are creating a multi-point sub-interface connection, and all these circuits are associated with this multi-point sub-interface using the frame relay map IP address. So this method assumes that we are going to use a static way of mapping. But remember, as I've shown you, you can use the other configuration not covered in this book, which I've just shown you, to set up multi-point configuration, sub-interface configuration, without having to assume that the multi-point connection has to be static mapping.